All right, we were working in section 2.2 last time and learning some of the basic derivative rules, and we had gotten to the point where we were going to take a look at number 9. Number 9's directions are different than the ones we have done before. They tell us that they want us to find the point on the function, if there is one, where there's a horizontal tangent line. Okay, so if a tangent line is horizontal, so just in your, throw up your arms. Show me in the air what horizontal looks like. Oh, that's good. You guys got to go the right way. Horizontal is like the horizon, so we're looking at a line like this. What would be the slope of a line that looks like this? It'd be 0, right? So if you're looking for a horizontal tangent line, you're looking for a place where the slope is 0. So how do we find slope for a curve or an equation? We're going to equal to 0 when we're done, but what are we going to set equal to 0? The derivative. Okay, so we're going to take the derivative first, right? All right, so let's take this derivative. What is the derivative of 2x cubed over 3? 2x squared, right? That cubed will come down, and it will cancel with the 3 in the denominator. What's the derivative of x squared over 2? Just x, right? The 2 comes down, cancels with the 2 in the denominator. How about the derivative of negative 3x? Yeah, negative 3 actually, right? Yeah, and then the derivative of 27? That'd be 0. So we can write that if we want. We don't necessarily need to. But just like Caleb said, what we're wanting to do is set this all of it equal to 0. And the reason we know that is because it talks about this idea of horizontal tangent lines. Right? Horizontal tangent lines have slopes of 0. So how are we going to solve this? Factoring. If we can, we'd like to factor it. Just this one will factor, but let's just say for the sake of argument right now, let's say it didn't factor. What options would you have? Quadratic formula. And there's another one that you'd never do, but do you remember it? It's called completing the square. That's actually another option too. Nobody ever goes that route, but it is there. It is an option. But we can factor this one, which is maybe the cleanest way to do it when it works. All right, so how will this factor? Two x and x, right? Do I need to run through this again? Going to have a negative and a positive. Which one's where? The 1 is with the 2x like this. So then we'd be plus 3. Does that work? Not going to work. How about minus 3 here and plus 1 over here? Will that work? Well, I've got a negative 3 coming from here and a positive 2 from here. You may have your signs in there reversed of mine, though. And if you do, then you can just switch their signs. Okay, does this look okay? Okay, so if I set each of these now equal to 0, what is the first one going to equal? 3 halves, very good. And the second one? Very good. There is one thing that we haven't quite done yet. Look at the directions again, how they're worded. What does it say? Points. Points have both an x and a y coordinate, right? And I mean, I found 2 values, but they're both x values, yeah? Okay, so if it wants the points, it means that it wants the x and the y coordinate. So this is 3 halves, and I need to figure out what the y coordinate is with this. And this is a negative 1, and I need to figure out what the y coordinate is for this. So how do I find out what the x or the y coordinate is when I know the other one? Yeah, I plug it into the equation, and that's really helpful because I've got an equation I can work with, right? So if you grab your calculator, this would be a great calculator activity. And make sure you're plugging in the original equation, not the derivative. You plug it in the derivative, you're going to get 0. So that's the slope. Don't fall over, Hudson.
I left my calculator on my desk.
Okay, it's all right. So somebody tell me when you put in 3 halves what you get. You can do it fractional form or decimal form because this one's actually a terminating decimal, so it doesn't matter necessarily which one you use. I already have mine written in fractional form, but I'll write the decimal form down too, just for fun. You're going to have a 1.5 something and a negative 1 something. When you find one of them, let me know what you found. Did you get one, Evan?
Yeah.
Which one did you get?
I got both.
Okay, what did you get for, do you have decimals or fractions right now?
Decimal.
Okay, what do you have the decimal for 1.5?
23.625.
Does that look right for everybody else? How about for the negative 1? What's the decimal form?
28.833.
Okay, so the 3 is what's repeating, right? Like that. So we don't usually like to write the repeating bars, mathematics. It's just not real pretty. So if you do, it's okay. But if your WebAssign doesn't allow that, which I don't think it does, I think we've tried that once before with someone in my office that doesn't allow the repeats, you have to turn them back into a fraction, right? So let me remind you in case you haven't seen, not maybe remind you, maybe tell you if you've never seen it before, your calculator will allow you to turn something back into a fraction really nicely. So let's say you got that repeating decimal down there at the bottom, 28.83 repeating, and that's what's on your screen right now. If you hit math, the button that says math, the very first one in there says frac. Just choose it and hit enter. And then back in your regular screen, hit enter one more time, and it'll take whatever you had before and turn it back into a fraction. It's a very handy feature, and the fraction that corresponds to that one is 173 over 6. The fraction corresponding to the other one is 180, yeah, so I thought it was 189 over 8. As long as you have the repeating bar, for me, I'm fine with that, but WebAssign probably isn't going to be. You're probably going to have to enter that as a fraction, so just use that extra feature in your calculator to get that. Any questions on that one? All right.